Hi, welcome to Internet of Things tutorial from Robojax. In this video we are going to use MQTT and subscribe and record the information or a temperature online. For example, if I press a button, the temperature has been recorded. If I press it again, another recording. And also I can send a message to turn on this LED from the web. Goes to the MQTT broker. This is just one way, and then this temperature is listed or queued on the cloud here. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery. And it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. In this lesson we are going to use the NTC or the temperature sensor with an LED and with a push button with ESP32. Right now it's connected to the battery. So every time we want to publish the temperature on the MQTT server, so we just press this button. This has been programmed like this. The temperature from this will be published to the internet, and that's it. So anybody else who needs it, they can pull it up. Then we are going to use this as a subscriber. We will subscribe and pull the information, and on the screen we can say for the LED to be on or off. ESP32 will pull down the information from subscriber from specific topic, and if the message says off, it will turn it off. If the message says on, it will turn it on. Let's have a look briefly at MQTT. So MQTT stands for Message Queuing Telemetry Transport. And why it's important? Because it's lightweight and very efficient. It's bidirectional, which means you can send and receive. It can scale to millions of things. It's reliable messaging delivery. It is secure, and it's persistent over unreliable network. So we have a mobile device or a computer, and then there is a temperature sensor that is used with ESP32, for example, to measure the temperature, and we want to see the temperature on the screen. For that, we need to have an MQTT broker. This is a cloud service that is ready to log or receive information. So this device is now sending or publishing this information to the cloud. And then this device is a subscriber. It subscribes to certain topic and it will receive the information. This device, if this device is off, the information will go and stay there until you can pull it up, pull it down. Or when they, so this publisher does not care about the person who is receiving it. And here, Internet of Things, for example, there is a connection and we have a temperature sensor data, then it goes to the MQTT broker. This is just one way, and then the temperature is listed or queued on the cloud here, and the client is a subscriber. They subscribe to certain data list or topic, and they will receive information. Come to this page, docs.sunfounders.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and then scroll to 8.4, IoT Communication with MQTT. This is the documentation page where we will learn how to utilize MQTT protocol and communicate and send and receive information using our ESP32 board. We're going to use our ESP32 board, the camera extension board, breadboard, jumper wire, resistors, LED, push button switch, and our thermistor. Here is the wiring. We already used all of this. We had separate projects for push button. Please make sure to watch that video so you understand it. I'm not going to explain it. We had an LED fade or LED turn on video. Please watch that. I've explained how LED works and how to connect and fade it or turn it on and off. And we had another video for the thermistor or NTC, and please watch that. We are combining them all together here, and we will be using pub sub client library, which we used in the previous lessons. This is the code which I'm going to explain it. Here is some explanation for the code as how it works and how to modify the code for our purpose, which is we need to use HiveMQ web client, which I'm going to show you step by step. Let's click on this. From this page, at this point, just click. It will open this screen for you. Our code is ready, so we just click here to connect. Now this is connected and ready for us. Here we create a new topic. Let's name it SF SunFounder, for example, LED, and create subscribe. One is created, and now click another one, and let's create SunFounder temp or temperature, and subscribe. This is now ready. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. Now let me show you the wiring. First we will start with a thermistor. The thermistor has been inserted. The right pin is connected to the blue line. Here I have set this blue from bottom all the way. This is ground, and this side, the red side, is 3.3 volts, where I connected from the ground this black wire to the ground. The second pin is ground. Also the second pin on this side is ground, and then 3.3 volts is connected to the first pin on the left side, where the USB is facing this way. This pin is connected, the right pin is connected to the ground, the right pin is connected to the ground, and then the left pin is connected to a 10 kilo ohm resistor, where it is connected to a point. The 10 kilo ohm resistor is connected from the left pin to some point here, and from here I've connected a red wire to 3.3 volts, and a red wire is connected to 3.3 volts. The line where the left pin of thermistor and resistor meet at this point, it has been connected to pin 36 using orange wire, and I've connected orange wire to pin 36 here. The USB is this way, this is 36. You can connect it also in here. Now let's go to the LED. LED has a longer pin. This is positive. Positive is facing this way. I've inserted such that From the left pin, a yellow wire is connected to the ground. Here, from the left pin, black wire is connected to the ground. From the positive pin or from anode, it is connected using 220 ohm resistor to a point, and 220 ohm resistor is connected to this point, and from that point a yellow wire is connected to pin 4, and from this point yellow wire is connected to pin 4 in here. Let's go to the push button. Push button is inserted on both sides of this line, and the right pin is connected using, if the push button doesn't fit, just rotate it, it will fit. The right pin is connected to 3.3 volts. The right pin is connected to 3.3 volts here. And the left pin is connected using 1 kilo ohm or 10 kilo ohm to a point. This resistor is connected from this side to a point in here, and it is connected to the ground, and from here it's connected to the ground. From the pin, the left pin of push button and the resistor, we have a blue wire connected to pin 14. From this point, I've connected this blue wire to pin 14 in here. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads, then ESP32 Starter Kit Main on the right side. Double click to open it, double click on C, double click on Codes, and scroll down to IoT. IoT 4, MQTT, double click and select the file, click Open. We have installed this in a previous lesson, this pub sub. If I select and right click copy, if you have not installed it, click on this icon, or right click here and paste it, and you will see pub sub by Nick O'Leary, and you will see install button if you have not installed it. I've already installed it, so this is done. Here we will enter our SSID for our Wi-Fi. Mine is DARS, and respect the D if it's lowercase or uppercase. The capital D will not work in my network. This portion is already ready. This is the MQTT server. This is unique identifier, and then from PubSub we create an object called client and pass the ESP client to it, and these are variables that are holding the message length. So LED, our LED is connected to pin 4, and push button is connected to pin 14. The thermistor pin is 36, and then the reference voltage, this is all for the thermistor. 3.3 volt is our voltage. The NTC value that we are using is 10,000, and the maximum value, the beta for the calculation is, which I've explained it, and this is the nominal temperature that we use for our calculation, and this is the nominal resistance. This was a resistor that we put, and this is the resistor for our NTC, which I've already explained it. We're initializing the serial monitor, setting up the Wi-Fi. This is a function. This function is in here, 10 millisecond delay. It prints this text, including the SSID, and this is connecting with SSID and password. This function is checking if the status of the Wi-Fi is not connected. This is a constant, it compares it. If it's not, then print the dot every half a second. And this is just printing a text, and will print our IP address. Now let's go. This uses a client test server. This will connect to this port, and then we have a client set callback. The callback is a function within our program, which I'm going to show you. Here is a callback, and when we call this function to pass it to this function, what it does is it gets the topic and message and length, and it comes here. It will print the topic and this text, and then we are getting the message. I've explained it before, one by one, and we are printing it as a character because it will print each character one by one, and then we will attach each character to this message variable, and here we check it. If the topic is equal SF_LED, then we print this on the screen, and then we SF SunFounder, for example, LED, and create subscribe. We check if the so first we check the topic, make sure we are in the same topic of subscription, and then we check if the message is equal on. Then we print this on the screen, and then using digital write we turn the LED pin to high, else we turn it off. I can send a message to turn on this LED from the web and turn it off. So this was a callback, and this is turning the push button as setting the push button as an input, and then LED pin as an output. Here, let's have a look at the loop. Inside the loop, this function checks if it's not connected, then we use the function reconnect, and reconnect comes here. It checks if the client is not connected. It tries again MQTT, it prints this text, and it checks this text and this function, and if the result is equal true, it will print connected, and then it goes to client and subscription of this path for us. Else, then it will print this on the screen, and it will try again if in 5 seconds. 5 seconds is this wait time, and it does all this all over again. So, and if the connection is okay, then we come to the client loop. It goes to the client loop, which is part of the library. It will run all the tasks, and here we using digital read, we read the push button. If push button is pressed, we remember the current time using millis. Millis is a function that runs from the time that you turn on your ESP32 or Arduino, and in 1 second this value will be 1000, in 10 seconds it will be 10,000 because it's a millisecond, and we hold it here in a variable of long, and then we check if now because this value is always greater than any other previous value. We check it if we subtract the value from the last message, if the difference is greater than 5 seconds, then we remember the now, which is this value. We store it in a variable called last message, which is defined at the top of the code, and then we define an array of character of length 8, and then from this temperature extract we get the value of string temperature, extract it from this thermistor, which is at the top of the code, and we store it in this variable, and then we publish it using client.publish to this feed. So this value is published to this feed. Now let's see the thermistor. Thermistor is a function that reads the temperature. I've explained it in previous lesson. Please watch that. So this is simply returning the temperature in Celsius. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here now it's connected. If I disconnect this, one of them disappear. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Now our code is ready. Let's click to upload it to the board. Hello? Okay, so as you can see, it says connecting and it's connected. Now we can click on this push button to see if it can send the temperature. So when I pressed it, we read the temperature. Let's go to this. And here it shows that temperature already have arrived because we have published it here. And I'm gonna press it one more time and another temperature came, so I can press it again and do that. So this is for the message. Now LED, this turn on the topic SF LED, and here this is off. I wrote it incorrect. So now it's ready. If I click on this, the LED is on, and if you want to turn it off, just say off. That's a message, and it's off. And at the bottom here, it shows what we did. So on, and it will work, and the temperature is also shown. And if I press the button, you will see that the temperature is red. The last record is in here. And the LED is on. Let's turn it off. And click publish, pay attention. And we can do that. Now, this way we have subscribed and we are sending temperature, publishing it on this portal on HiveMQ, and the people who have subscribed will pull it up. For example, for the LED also we pulled it, which says SF LED, and that value was off. When we pulled it, this was turned off. And the same way, if somebody writes there on, and when we pull the information, you can see that this is on now.